Hello everybody, Namaskar. Now we are running in the 8th module where we are discussing various aspects of the processing of plantation crop products. In the last lecture, we discussed about tea and tea products. In this lecture, we will study about processing of coffee, another very important plantation crop products of the country. So, we will discuss what is coffee and various types of coffee is made, processing of coffee, that is wet and dry methods, roasting, grinding and packaging operations of the coffee beans. Then we will also discuss about instant soluble coffee and various methods of coffee brewing or extraction, and finally decaffeination of coffee will be studied. So, coffee, its botanical name is coffea. You know, it is evergreen shrub or a small tree. It is indigenous to Central Africa and Asia, and coffee is the third most popular beverage in the world. There are three major species of coffee, that is Coffea arabica, Coffea robusta and Coffea liberica. Coffea arabica and Coffea robusta are the two varieties which are most commonly used worldwide. You can see here in the figure, that is arabica and robusta coffee cherry, how do they look like. Arabica is the perhaps gives the largest and best quality beans. However, it has low yield, it grows at higher altitude, it has delicate aroma, and it is mostly grown in Brazil. Brazilian coffee are mostly of arabica variety. Robusta, it gives a little inferior quality coffee beans in comparison to that of the arabica. However, its yield is high, it grows at lower altitudes, it is resistant variety and gives a strong decoction, and this coffee is mainly grown in India, because Indian consumers that they like the strong decoction. Okay. About coffee plantation, the unprocessed seeds of the coffee are planted and grown into a coffee tree. The planted cherries are harvested depending upon its variety. Normally 3 to 4 years are required for a tree to bear fruits. The harvesting of the coffee cherry is done in two ways. That is, one is the strip picked, in which all of the cherries are stripped off the branches at one time, either by hand or by a suitable machine. Second method is selectively picked. Here only the ripe cherries are harvested and they are picked individually by hand. Pickers move among the trees by a rotation of every 8 to 10 days, choosing only the cherries which are at the peak of their ripeness. And because this kind of harvest is labor intensive and more costly, it is used primarily to harvest the finer Arabian beans. In this slide, I have just shown you the steps that are involved from the coffee farm to consumer table. That is, in the farm how it is grown, and then finally that different step: harvesting, processing, milling, sipping, roasting, grinding, packing, brewing, and finally enjoying the coffee beverage. Okay. You see, please have a look at this structure of the coffee cherry. That is normally it is deep yellow, red yellow when it is ripe. Okay. Upon drying, that is, if you cut open the fruit, you will see that outer side it is a fruit husk, and inside the husk there are two flattened coffee beans or cotyledons, and which are the actually valuable source of the coffee beverage, that is coffee powder. Okay. So, here again the coffee bean structure is shown. It's a cross section through a coffee cherry, Okay, and see that inside these are the coffee beans which are covered by a thin parchment like silver skin, and then parchment, and then it is a fleshy pulp, and outer side is that is mucilaginous pulp, and then it is the outer coverage. Okay. So, basically when we talk about coffee processing, it involves the removing skin, pulp, parchment and silver skin, that is outermost covering skin, then the pulp, parchment paper and silver skin which surround that bean. So, these are removed using appropriate methods, and that is the processing of coffee. Here it is the schematic of the coffee processing is shown. In fact, there are two methods normally used, either dry method or wet method, and obviously the quality of the coffee bean, processed coffee beverage depends significantly on the nature of the or method of the processing of the coffee beans. In dry method, it is very simple. Okay. It is you see here the coffee cherries, after they are plucked from the tree, they are just dried, then dehulled, because during drying that there is a its mucilaginous pulp etc. is dried out, or you get a thin thick hull or husk type of things. Then just by simple dehulling, by hulling the husk is removed and the green coffee beans are obtained. Whereas in the wet methods, which is normally gives a comparatively better quality of coffee beans, that is the wet cherry, that is cherry is subjected to pulping, then fermentation and washing, followed by drying, peeling and polishing, and finally we get the green beans. So, in the pulping, obviously that outer pulp is removed by squeezing or suitable machines. Then in the fermentation, mucilage and other are removed, and it is that is huge amount of course in this method water is used for the washing and removal of the mucilage, and this in the peeling and polishing the parchment and silver skins are removed. Okay. So, the processing obviously must be done quickly to prevent the fruit or cherry from spoilage. The beans are dried up to 12% moisture for storage. The dried beans are known as parchment coffee and are warehoused in just in jute or sisal bag. The dried beans are dehulled and polished. Hulling removes the parchment layer from the dried beans, and polishing, which is optional sometime, it is here it is a silver skin is removed. Okay. So, let us have little details of the both dry as well as wet processing. In the dry or natural processing, as I told you that you can see here in the figure that the beans are sun dried by spreading them out on the drying floors, and the coverings are removed by simple hulling method using a suitable roller or dehuller. Okay. The beans are later cured in curing sets, and the product obtained thus in trade is known as cherry or native coffee. Then wet or washed coffee process, it is done mainly in Central America and Colombia to produce washed coffee. It produces better quality beans. In this method, after pulping, the outer layer of the mucilage is removed by spontaneous fermentation. This is sometimes facilitated by added enzymes. The seeds are washed and subsequently dried to a moisture content of about 12%. The green seeds are then graded and packaged. The green coffee as produced by wet method can be stored for prolonged period of time without any adverse effect on its quality. Then very important operation comes the roasting. In fact, raw or green coffee bean which is obtained by dry method or wet method has no flavor or aroma. Rather, because of the presence of various polyphenolic and other compounds, it has unpleasant taste. So, actually the green coffee does not smell like a coffee. So, it is roasted. During roasting, about 1,000 different compounds, aromatic compounds are developed, and these compounds make the or give the coffee its a characteristic flavor. The roasted coffee is powdered and brewed, producing aqueous extract which is used in beverage or with or without milk, sugar and other substitutes. Okay. Different degrees of roasting result in various levels of aroma and taste development in the coffee, which have different applications. You can see here it is the coffee is being roasted in a batch roaster. Okay. The commercial roasting parameters may be about 15 minutes 4 batch roast at 427 degrees Celsius, or 5 minute, that is 10,000 pound per hour continuous roasters at about 380 to 320 degrees Celsius. So, the various degree of roast may be light roast, medium dark or dark roast and so on. The roasting of coffee beans causes various chemical reactions due to heating at different temperatures, and these results in the production of aromatic compounds, acids and other components. These compounds are created, are balanced, are altered in such a way which result in the perfect flavor, acidity, aftertaste and body of the coffee. In fact, this proper roasting is a very important operation as far as the characteristic flavor and color development of the coffee beans is concerned. So, major reactions which occur on the bean during coffee include Maillard reaction, caramelization, first crack, pyrolysis and second crack, etc. And this is depending upon the time. During the time, that is for the initial 2 to 3 minutes there will be drying, and then after 3 to 8 minutes there will be yellowing, which is followed by, that is the first crack, and then once it is first crack, then there are minute development inside the bean which leads to the pyrolysis, finally second crack, and then further development of the compounds. So, Maillard reaction and the caramelization, these are the two major reactions which are responsible for the flavoring compounds development or coloring compounds development. Okay. When the coffee is roasted at temperatures from 150 to 200 degrees Celsius, carbonyl compounds, that is these different types of sugars etc. which are present, and amino groups in the protein react to form aroma and flavor compounds, and hundreds of coffee flavor compounds are developed there by Maillard chemistry, including the potent coffee aroma compound 2-furfuryl. In caramelization process, that is when the further temperature goes maybe up to 170 to 200 degrees Celsius, sugars in the coffee start caramelizing, which browns the sugar and then releases aromatic and acidic compounds. So, during roasting, most of the sucrose is converted to caramelized compound, but if the roasting is done too lightly, it will result in a better tasting. So, diacetyl, you can see here the figure, it gives the butterscotch flavor to the coffee, whereas furanones have a burnt sugar flavor. Then in the first crack, when the temperature further goes to around 205 degrees Celsius, water inside the bean vaporizes, causing the bean to expand and crack. Okay. And this first crack makes the bean double in size, and prior to this, bean changes from a green or yellow color to a light brown color. You can see here that is a different stages of the roasting, how there is a color of the bean is changing. First crack is followed by the pyrolysis at approximately 220 degrees Celsius temperature. Heat causes a chemical change in the bean, leading to the release of carbon dioxide gas. The change in color to a medium brown, and the bean loses about 10 to 12% of its weight, mainly moisture evaporation. Light roasts are done after this step. Acetaldehyde is produced during pyrolysis, and it has a green apple aroma. Then after the pyrolysis, the second crack There pyrolysis continues till the temperature reaches around 225 to 230 degrees Celsius, causing the second crack in the bean. The cellulose in the cell wall of the bean is broken apart. The bean is now medium dark brown in color and it has an oily sheen. Aromatic compounds are released which contribute to the characteristic coffee flavor. You can see here the different stages of the development of the coffee seed during roasting, changes in the color. Okay. 2-isobutyl 3-methylpyrazine gives coffee and earthy sheen, and 2-ethyl 3,5-dimethylpyrazine adds earthy roasted notes. Okay. So, I will summarize the physical and chemical changes occurring in the coffee bean during roasting. That is the number one, the bean swell in size to almost double their original size. The dull green color changes to brown and the characteristic coffee aroma develops. The beans lose their hard horny structure and become brittle, with the outer surface still smooth and firm, and this facilitates the next grinding operation. About 10 to 12% of the moisture is driven off, followed by caramelization of sucrose and finally pyrolysis of the carbohydrate and protein within the 40 micron cell when internal pressure is developed to about several hundred psi. Carbon dioxide is produced in a comparatively large quantity during roasting, and some of it escaping and some being absorbed with the texture of the roasted beans. Volatile fatty components like fatty acids etc. are driven off, and the complex fats and waxes are cracked down to simple ones. Proteins may be hydrolyzed and they may give cleavage product, and all these contribute to the flavor of the coffee or color of the coffee. Now, next operation is the grinding of the roasted coffee bean, and the purpose of grinding is to facilitate later water extraction of the roasted beans. Because this you have seen in basically in the coffee that there are water soluble coloring and flavoring compounds, and these are extracted in the brew and we get the coffee beverage. So, granulation used in the soluble coffee extractors are coarser than the regular grind. The different regular grind or drip or fine grind, these are given here in the table specifications etc. Nowadays, domestic electric percolator grind is used, which gives all purpose grind for which there is specifically no industry standard, and these grinds vary greatly, but they are often being same as that of the regular grind. In fact, regular grind, that is the about 33% of the coffee is retained on 10 to 14 mesh sieve, and about 55% of coffee is retained on 20 and 28 mesh sieve, and amount of the coffee passing through the control sieve, that is 28 mesh, is 12% in the regular grind. Okay. Then packaging, very important operation about roasted coffee, because in fact roasted coffee beans stale in air at room temperature within 10 days to 40 days, maybe within a month, depending upon the environmental condition. Ground coffee is still within few days, but is tolerable to consume up to 1 week, depending upon the ambient temperature, humidity, air exposure, and of course the drinker's choice or drinker's tolerance to the stale taste. So, upon storage, the carbon dioxide which was produced during roasting and retained in the structure or texture of the coffee cherry is lost, and so are the flavor and aroma compounds. Coffee exposed to moisture loses its entire flavor in a relatively shorter time. The loss of flavor in vacuum packaged coffee or the coffee packaged under pressure using carbon dioxide is less. And even it has been seen that in the vacuum package, one particularly vacuum pumps etc. machine is used to create the vacuum, there is at least about 1% or so residual oxidation is remains in the package. So, even this residual oxygen inside the package is also very deleterious, and it creates oxidation and undesirable changes. So, basically that nowadays inert gas or nitrogen flushing nitrogen plus packaging in the flexible bags has become more common, okay, and which gives protection in freshness up to about 3 months. So, accordingly, that is the coffee beans, its roasting, grinding, and these and then finally packaging of the roasted coffee beans or grounded coffee beans should be properly planned, so that the grounded coffee beans do not stand in the market more than 3 months, etc. They are consumed with accordingly that the planning should be, production planning should be done. Then important product is the instant soluble coffee, okay, that method for the preparation of instant soluble coffee, okay. So, in fact, that is like we make brew in our home, that is in the hot water or hot milk, coffee powder is in. So, the same process in fact is used at the industrial scale. First the coffee, that is the water soluble components present in the coffee cherry or roasted coffee beans, they are extracted using 6 or 7 extraction columns. In these columns, that is hot water at around 176 to 80 degrees Celsius flows in a counter current manner to the over the roasted and ground coffee within the column, where that overall hold time is around 3 to 4 hours, and it yields about 25 to 30% of the soluble concentration extract and around 40 to 50% of the soluble yields, okay. And these coffee you can see here in the whole process flow chart of specific coffee instant coffee process is given here. So, the extract which is obtained, this further concentrated normally either by vacuum concentration, but the method of choice is the freeze concentration process, and then this concentrated coffee beans are next into that. It has a concentrated coffee, it has a TSS of about 50% or so, and then this is sent to the freeze drying or spray drying, okay, where that in the freeze drying sublimation process is used, or in the spray drying that hot air, that is spray, it is atomized and we get the soluble coffee powder. Mostly the choice grade coffee is made by the freeze drying process, although industrial operation makes the spray drying better, okay. Classification of instant coffee powder, there are in fact non-agglomerated instant coffee powder, which consists of individual spherical bead like particles giving the powder its free flowability and good solubility in hot water and produced economically from spray dryers. Agglomerated instant coffee powders consist of either medium sized or large agglomerates with a minimum of fines, giving the powder superior free flowability and solubility in hot and cold water. Medium sized agglomerates are produced using spray dryers, whereas in large agglomerates spray dried powders are rewetted and again dried under controlled conditions. The principle of agglomeration we studied in the earlier class. Then granulated instant coffee powder, in this large granules free from fine particles giving excellent free flowability and solubility in the hot water, they are produced. These are produced normally in freeze dryer for maximum aroma retention. Then brewing of the coffee extract, okay, that is brewing means that is extracting the coloring and flavoring compounds and getting the beverage, coffee beverage. Coffee extraction is carried out at different scales, such as in the industry for instant coffee, vending machines, etc. are used for brewing, okay, or even at a household level a single cup of the coffee is needed, and accordingly it is used either by boiling or by other methods. Here for brewing purpose, for extraction purpose, the intimate contact, as you can see here in this figure it is shown, intimate contact between the hot water and roasted coffee solids is required for transferring of the flavors from the ground coffee bean into the water matrix. Types of coffees, extraction methods and process parameters decide the quality of the extracted coffee. Extraction methods, majorly decide the quality. However, the degree of roasting has some role in quality of the extracted coffee production. So, the process variable may be extraction time, water temperature, pressure, coffee to water ratio, particle size of the coffee powder, water quality, and so on. The extraction method maybe the decoction methods include boiled or Turkish method or vacuum method, as you can see here in the figure. And in this method basically that is it requires prolonged contact between the solid and the water, you can see here. In the infusion methods, like in the making filtered coffee, the hot water flows, as you can see here, hot water flows through a coffee bed, allowing a short contact time. So, the soluble flavoring and coloring compound, they are extracted and they come in the coffee brew. The pressure method like plunger, French press or stovetop coffee maker or mocha or espresso coffee machine. You can see here schematically that principle of operation of all these systems are shown here in the figure. Basically, here the pressure is used. Pressure is required for the continuous or uniform flow through a compact bed of the coffee cake, and it is made, which is made from the ground coffee or coffee powder. Okay. You see in the espresso coffee, that is this coffee grounds or cake is put here and the pressurized hot water is flown. Okay. And then in the brewing chamber, there is a filter medium, it filters and the coffee brew is obtained. Okay. In this slide, I have given just a comparison between the instant coffee, I have taken it from the literature, and the freshly brewed coffee. 1 cup of the instant coffee contains about 60 to 80 milligram of caffeine. It has less chlorogenic acid, high phenol and flavonoids. It is of course has low cost, and convenience is the key advantage of this. There are no byproduct and less time is required in its manufacturing and production. Whereas the freshly brewed coffee, it contains 60 to 120 milligram of caffeine per cup, more chlorogenic acid, low phenols and flavonoids. It is expensive process, but it has been in the traditional ritual process in many countries it is being used, and byproducts there are some, and it is a time consuming method. Then another important aspect about the coffee processing, and now in the market there are decaffeinated coffees. In fact, as you have seen in the last slide, that is both that instant coffees as well as regular coffees, they contain significant amount of caffeine, about ranging from 70 to 140 milligram of caffeine per cup. And this caffeine, when you are using, and if you take per day 4 to 5 cup of coffee, so you can imagine how much caffeine you are consuming, and this caffeine goes on accumulating in the body, and then in the when the caffeine or excessive intake is there in the body, it can influence the central nervous system and can lead to sleep problems, restlessness and discomfort, etc. That is called extreme caffeineism. So, for the people, those who are sensitive to caffeine or those who want, although the caffeine is the stimulating agent, it is a stimulant and gives the stimulating action after we consume the coffee or such other drinks, but excess of anything is bad. So, this caffeine is removed partially or fully, and even zero caffeine coffee can also be made available using special decaffeination methods. So, commonly used methods for decaffeination include solvent extraction, supercritical carbon dioxide, or water decaffeination methods. Okay. The solvent based decaffeination, it uses solvents to selectively remove caffeine. Solvent normally used are methylene chloride and ethyl acetate. You can see here the process flow is given. It can be a direct method or indirect method. In the direct method, beans are steamed, then soaked in solvent to remove caffeine before being steam dried and roasted. In the indirect method, beans are soaked in hot water, then mixed with solvent to remove the caffeine. The supercritical carbon dioxide decaffeination methods, green coffee is treated with the steam to make it permeable and to facilitate the extraction of caffeine by liquid carbon dioxide or that is supercritical carbon dioxide in the first step. Then here in the second step, the beans are contacted with the carbon dioxide under supercritical conditions at a particular pressure and temperature, where this flavor, that is caffeine, is solubilized in the supercritical carbon dioxide, and then it is taken decaffeinated coffee you get from that extraction chamber, and then caffeine mixed carbon dioxide, liquid carbon dioxide, then depressurized and caffeine is removed. Okay. So, at high pressure, as I told you, carbon dioxide, you can see here in the figure, carbon dioxide dissolves the caffeine is removed from the carbon dioxide with water or recirculation, and the whole process takes up about 12 hours or so. And this is commercially used to this CO2, supercritical CO2 is used commercially for separation of caffeine from the coffee powder. Then water decaffeination process, it is shown here in the process flow chart is shown here in the figure. There is a Swiss water process or a French water process. In the Swiss water decaffeination process, beans are soaked in hot water to remove caffeine and flavor compounds. Caffeine is removed from the water by filtration, but flavor compounds remain. The flavor saturated water removes caffeine from further bean batches without any flavor loss. Whereas in the French water decaffeination process, beans are soaked in hot water, generally in boiling water for 24 hours. The beans are then removed and dried, and water is filtered to remove caffeine. The caffeine free water is added to the dried beans for reabsorbing the flavor compounds. Okay. So, finally, I would summarize today's lecture, that is, coffee is a very important product, major product of India. India also produces significant amount of coffee, okay. But the coffee cherry, there is a need that is for plucking the cherry, that maybe AI tools or robotics etc. should be developed using modern, because during the plucking process also the care has to be taken that the leaf that is the cherry should not be damaged, all right. And also in the plant at a time there may be some cherries which are ripe and there may be some cherries which are not ripe. So, only those ripe cherry, if they are plucked at right time, and these cherries after they have plucked from the tree, then they are subjected to series of operations like either its processing, removing the outer coverage etc., getting the inside seed, and then these seeds are roasted, and the proper roasting is very important. They are roasted under proper conditions for development of color and flavor, and then these roasted beans are ground into powder of a proper particle size. Okay. That is, even the particle size of the roasted coffee beans is also important, because it facilitates the later water extraction etc. And then even the soluble instant coffee or decaffeinated coffee are also produced, and they are available in the market. The technology process we have already discussed in detail. These are the references which has been used in this lecture. Okay. With this, I thank you very much for your patience listening.